Hello again and welcome to another GCSE Computer Science Theory lesson. This video is going to be on Unit 4, Storage. So first of all, we're going to talk about something called RAM. What is the purpose of RAM? RAM stores currently running programs on your computer. It's really fast. But I want you to think about, why do we have RAM? Well, first of all, let me just show you a little bit of RAM in action. So at the moment, on my computer, I have my recording software running in the background. I've got a bunch of operating system junk running here. I've also got some software called Sumatra PDF, which is holding my slideshow. What else have I got running? I've got Explorer.exe. If I were to open up Firefox, that would now enter my RAM. So what is the point of it? Well, we've established it is for storing things that are currently running. Well, why do we have to store things that are running inside the RAM? Why can't we just put them on the hard drive? Well, the reason for that is because hard drives are really slow. By the way, by hard drive, I mean this stuff here. So we can see that Windows, all the Windows stuff is in here, and all of my program files are in here as well. So why can't we just run our programs straight from the hard drive? It's because hard drives are just really slow. If we tried to run everything from the hard drive, we would have 2 to 3 second delays every time we clicked the mouse, every time we moved the mouse, every time we entered in a letter on our keyboard, there would be a 3-second delay. We put it in RAM, it goes super quick, so quick to the point where you don't even notice any lag. Well, most of the time. Okay, so anything outside of the RAM that we call it secondary storage. And I say any because there are some exceptions within reason, but any storage, anything that you save files onto outside of the RAM, we call secondary storage. And secondary storage comprises of hard drives, USBs, and optical discs, for example. There are other types out there like magnetic tape discs and floppy drives, but those are all really old school. But these days, most people only come across hard drives, USB drives, and maybe these things are being phased out at the moment. It'd be interesting to see how many of my students watching this actually use optical discs still. But maybe you still use them for some video games and DVDs. Who knows? Okay, why do we need secondary storage then? Well, if RAM is... Well, this RAM here is really fast. Why do we need secondary storage? Like, I mean, 6 gigabytes. I could save a small operating system on there and I could put all my files on it, couldn't I? Why can't I just save all of my work inside the RAM and then everything is really quick? Well, we can't do that because RAM is what's known as volatile. And volatile means that data is lost when the power is lost. So every time you turn off your laptop, everything in your RAM gets emptied. It's just the way RAM is designed. So we can't save things to RAM because it will get wiped whenever we lose power. So we need to save things to a hard drive or a USB drive instead in order to preserve our data. Okay, so now I'm going to talk about those individual pieces of secondary storage in more detail. So I'll start off by talking about hard drives. So the way hard drives work, and this is an example of a hard drive with the case ripped off it. So underneath there, you can actually see there are spinning disks inside a hard drive. That's why it's called a hard disk drive, because there are actually disks inside it. They work by using magnets in short. So they use little magnetic regions to read and write ones and zeros to the disk. We don't need to know too much detail about this, but everything you do need to know for the exam is just that it uses magnets to read and write ones and zeros, and these spinning disks are made up of something called tracks and sectors. Now you don't need to recall this for the exam, but I'm going to do a terrible diagram in Paint just to explain it to you in more detail. Okay, so I'm going to do a really shabby drawing of a disk here, or more accurately, a hard disk. Do bear with me. Okay, so let's pretend that this is a hard disk with the case removed off it. So yeah, there's the little pointer thing that's going to be reading all the ones and zeros. And there we go. So this circle thing in the middle, that is the spinning disk that contains all our ones and zeros. Now logically, this is allegedly grouped into something that is known as tracks and sectors. And let me just go for a different pen color. Okay, so when we say tracks, we mean rings that are going out. So there you go. So here are our tracks. So there we go. So for example, this area would be track 1, this area would be track 2, track 3, and track 4, for example. And when we talk about sectors, we mean these little lines, or columns, or whatever you want to call them. But the terminology we're going to be using in computer science is called sectors. So when we talk about sectors, we mean this. So for example, this could be sector 1, and this could be sector 2. So if we wanted to, we could say that this point by here is track 2, if we were starting outwards, going inwards, so 1, 2, or maybe you're going 1, 2, and 3. It doesn't matter at the end of the day. This is just GCSE level. We could say that's track 2, sector, well, whatever you want to call it, sector 1. Okay, solid state drives. They are quite different to hard drives. They just use electrical circuits to persistently store ones and zeros. And when I say they just use electrical circuits, it is really, really complicated how they actually work, but we don't need to know about it for GCSE. This is a perfectly acceptable answer in the exam if they ask you how an SSD works. That's all you need to know. And this here is a picture of a solid state drive with the enclosure ripped off it. And as you can see, it is just circuitry with some chips there. By the way, if you're interested to know, these little black chips, that is where our ones and zeros are stored. The rest of this circuit board is just interfaces to allow the computer to communicate with those chips. And this here, this little black chip at the bottom, if I'm not mistaken, I think that's actually a very simple processor that allows these chips to communicate with this little port here known as a SATA port, which then communicates with the motherboard on your computer. But you don't need to know that. Okay, so at a glance, the advantages and disadvantages of a hard drive versus a solid state drive. Well, hard drives offer higher levels of storage. So as of creating this slideshow, as far as I know, hard drives are typically measured in their terabytes, which is pretty good. And it will normally set you back about 30 quid for a 1 terabyte hard drive. On the other hand, a solid state, it will set you back 30 quid for about a 32 gigabyte solid state drive. So comparably, hard drives, you get a lot more storage for your money. Solid state drives, you get less storage for more money. Okay, but there is a reason why we prefer solid state drives, because solid state drives are considerably faster and they actually use less electricity, whereas hard drives are actually slower and use more energy. The reason why this is the case is because of the mechanical disk. The mechanical disk is what is causing that slowdown. There are actually some physical limitations by how fast you can spin the disk before it shatters or gets scratched by the little needle head that's reading it. We don't have those limitations with solid state. The same for energy. The reason why a hard disk drive uses up so much electricity compared with a solid state is again because of that spinning disk. Another bad thing about hard drives is that they are vulnerable to shaking. If you were to drop or shake your hard drive, there is a good chance you are going to scratch that disk against the head that moves along it. Whereas a solid state drive, there are no moving parts, so you can shake it as much as you want, which means solid state drives are ideal for things like smartphones and tablets and laptops. Now, there you go, look, if you wanted to, you could shake your solid state drives like a pair of maracas. There's not really much point to it because they're not going to make any noise, unlike real maracas. Is it true that maracas are made of children's teeth, or is that just an urban legend I heard somewhere? Anyway, I digress off topic. Moving on. Optical discs. Optical discs, they use the magic of lasers to read ones and zeros from a disc. Those lasers reflect off these things called pits and lands. Now, pits and lands, you're going to need that terminology for the exam. Pits and lands on a disc are used to represent those ones and zeros. Now, I'm going to draw a really dodgy diagram for you in Paint, just to explain how these pits and lands work. So I'm going to draw a cross-section of a disc, and it's going to be a really bad diagram, so don't hate me for this. I'm just going to try and explain it as best as I can. So here is a... and I changed the colour. I don't like that colour. Okay, so here is the top layer of the disc. And when I say top layer of the disc, I mean the bottom layer of the disc. So here is a transparent layer of plastic that you can shine the laser right through. And this E here is going to be the side that has the label on it. So if it was like Shrek the Third, then you'd have a big picture of Shrek wearing a crown on this side of the label. And here is a transparent layer of plastic. And in this area, at the bottom, in the middle here, sandwiched between these two layers of plastic, is a very special material that's some kind of metal oxide that reacts to lasers or some garbage like that. Anyway, this is made up of what's called pits and lands, and it's got a weird bumpy texture. So you have a texture that's a little bit like this, and then you have a texture like this, and it's a bit like that. Something like this. Well, it's not quite like this, but this is dumbed down for GCSE level, so don't worry about it. And anyway, you put this disc in your computer, and a laser comes along and shines on this. And if this bounces back, if this is shining back at the computer, then it's probably a 1. Or otherwise, if it shines on this and doesn't bounce back, then it's going to be a 0, or vice versa. It doesn't really matter which way round we get this for the purposes of GCSE. But that's pits and lands for you. By the way, it doesn't matter which one you call pits and lands. As you can guess, this is probably a pit, as it is a pit. Okay, moving on. Some pros and cons about optical discs. Optical discs are cheap, and I say cheap-ish because it's depending on the scenario. So if you were selling a video game in a supermarket, it would be cheaper to put all of your games on a 50p CD than what it would be to put your discs on a, I don't know, a £10 hard drive, for example. So in that case, it's cheaper. But per gigabyte, hard drives are cheaper per gigabyte. But in terms of individual discs for deploying media, CDs are going to be cheaper and DVDs are going to be cheaper. Before I get to this, I'm just going to go to the negatives. Optical discs are very slow, and well, they're going to get scratched easily. I'm sure anyone who is old enough watching this video to remember DVDs, I'm sure you have lots of unpleasant memories of younger siblings scratching up your favourite Shrek movie. Okay, so I've sort of said usually read-only, and I say usually because there are optical discs that you can read and write to if you want. They just cost a little bit more money and they are less reliable, but generally speaking they're read-only, which is a good thing and a bad thing all at the same time. Like, take the DVD up. Like, I've got Up in my DVD case somewhere. You know, I like that film. I don't want anybody to overwrite it. That's a good thing. Yeah, I don't want anyone to overwrite that film. That is a really good thing. However, I've got quite a few Michael Bay films which I would love to erase and overwrite. I can't overwrite them, so that's a bad thing. Okay, up next we're going to talk about VRAM. So VRAM, that means virtual RAM or virtual memory, as it is sometimes referred to. So VRAM is used when you run out of RAM. So yes, you can run out of RAM. Your operating system does the best job it can to try and manage your memory. But in this example, I've got 6 GB of RAM. It is possible that I could have so much rubbish open on my computer that my RAM gets full. What is going to happen when my RAM fills up? Well, programs might start to crash. Or at least they used to. Go back to the 90s. If you used up all your RAM, your programs would crash and break and you would lose that essay you were working on, and that homework that was due in the next day would just go in the bin and you'd have to do it again. However, there is a solution. There is something called VRAM. So, modern operating systems these days, if you run out of RAM, there is a part of your hard drive that can be used and pretends to be RAM. This is a good thing and a bad thing. It's good because you don't lose all of your files. You don't lose things that you're working on. However, hard drives are really slow compared to RAM. So once you start dipping into your VRAM, everything goes painfully slow on your computer, and your hard drive is just busy reading and writing stuff to it. So VRAM, it's good because it stops things from crashing when you run out of RAM. But when you are using your VRAM, things go really, really, really slow. By the way, if you're interested in enabling or disabling VRAM on a Windows computer, I will show you now. So let's go to the Start menu, and we're going to go to this PC, and we're going to right click on this and go to Properties. And we're going to go to Advanced System Settings. And here we're going to see an option called Performance Settings, and go to Advanced, And here we've got it, virtual memory here. And we click change, and you can change it to whatever you want. I've got mine turned off to deliberately keep things fast, so I'm not constantly reading and writing garbage to my hard drive. But people who don't have much RAM might enable it just in case they run out of it. But there you go, so you can disable it to improve the performance of your computer, or you can add loads of it in there if you wanted to, just in case. But you are going to lose some storage space and things might slow down if you do that. Okay, finally, we're going to be talking about something called ROM. And I'm going to say, forget what your ICT teacher told you about ROM. Hard drives are not ROM. The reason why I say this is because there's a lot of misinformation there. There's a lot of ICT textbooks out there that say that hard drives are ROM. That is just completely not true, and there are a lot of misunderstandings as to what ROM actually is. So ROM stands for read-only memory. It is a special type of memory that you can only read from. You're not supposed to erase it, you're not supposed to overwrite it, you're not supposed to change it. It is supposed to stay a constant on your computer. So, because this thing is a constant, it is used for really important startup instructions and firmware on your computer. By the way, it's called firmware because it is firm. It's constantly in there, you know, firmware. For example, the BIOS of your computer. If anyone's not familiar with the BIOS, let me try and get some images on Google. I would show you the BIOS on my computer recording, but my operating system would shut down and I wouldn't be able to show you it. So here we go. Here's an example of BIOS. So these kinds of things here. It's the screen that comes up on your computer just as you turn it on. There's all this kind of stuff. That's your BIOS. The purpose of the BIOS is to allow you to install new operating systems. So you could technically delete Mac OS or Windows off your computer and replace it with something else. And you would use the BIOS to do that. If you were to accidentally delete the BIOS, you would have a very expensive paperweight. That's why the BIOS is stored on your ROM, so you can't accidentally remove it. The same goes for devices like Android and iOS. They have a ROM chip that contains really essential startup files, so you can't somehow accidentally permanently erase all the software on the phone, because you need some really basic primitive software at the start to allow you to add new software. But anyway, you don't need to know all of this in so much detail. All you need to know is ROM is for startup instructions. That's literally everything you need to know for the exam. But I thought I'd talk about the other stuff just in case you're interested. And by the way, ROM chips are tiny. These days, they're about the same size as a thumbnail on your computer motherboards, maybe even smaller. And in terms of file size, we're talking megabytes. They're absolutely tiny. Let me check file size. Let's just get some validation from Google here. 16 megabytes. So there you go. They are absolutely tiny.